Today we are going to be explaining integrals of trigonometric expressions and powers. Our identity is sin to the power of 3. We can see that it has a not power, therefore we need to use the Pythagorean identities. This is equal to sin to the second power plus cos to the second power is equal to 1. We need to separate them in order to be able to solve our examples. And when you have sin to the second power, it's the same as if you have 1 minus cos to the second power, because you're passing everything else to the other side. And when you have cos to the second power, it's the same as 1 minus sin to the second power.
In order to be able to solve these examples, we have to use this formula. This formula comes from separating the third power to sin to the third power. We're going to separate it into sin times sin squared. Here, as we can see, this sin squared is the same as this. So we are going to replace this sin squared with 1 minus cos squared in order to end up with sine of x times 1 minus cos squared of x.
In this problem, we have an odd number, so we have to break it in two and use the Pythagorean identities. To be able to solve it. Here we have the identity we're going to use in this problem. So we change it and we have 1 minus cos squared of 5x times sin of 5x dx. Then we have to multiply 1 times sin and then negative cos squared 5x times sin. And we get sin 5x minus cos squared 5x sin 5x. Then we use the formulas we already know to antiderivate. And we know that sin can be the derivative of sin is cos. And here we're going to use u 5x. And the derivative of 5x is 5. So we know, so we have sin u, which in this case is 5x, du over 5. And then we know that the antiderivative of sin is negative cos, so we can change it. Negative cos, our u in this case is 5x. And if we divide 1 times 5, we have 1 over 5. So that is the answer of the first part. Now we have to do the second part. In this case, we have to choose our u. And since this one is squared, this will be our u. So u is cos 5x. And u prime, we know that the derivative of cos is sin, negative sin. So negative 5 sin 5x. And now we can begin to solve. Negative u to the second power sin 5x du over our u prime, which in this case is negative 5 sin 5x. We can cancel our sin 5x and we are left with to the power and divided by the same one, which is 3. And we are left with positive, because we cancel negative, it's positive. Positive 1 over 15 cos u is cos 5x, and that is the answer of the second part. The answer will give us negative 1 over 5 cos of 5x plus 1 over 15 cos cubic cos to the 5x plus c.
The integral that we have to solve is 12 sine to the power of 3, 6x minus 5. In order to solve it, we have to identify that we have to use the Pythagorean identities. And because it is an odd power, we have to use this one. So we will replace this in sine squared. So we will get 12 sine 6x minus pi times sine squared 6x minus pi, because we separated the sine to the third power. And we replace 1 minus cos in sine squared. So we now multiply and use this derivative property to multiply this times this and this times this. And we will get this.
After we got this answer, we know that since it is subtracting, we can treat it as two separate integrals. First, we solve the first integral, in which we know that the u is 6x minus pi. So u prime would be 6, and we have to cancel the 12, but we get a 2. Since the rule of sine to cosine is a negative cosine, we have to add the negative sign. Afterwards, we're going to solve the second integral. In the second integral, we find that this whole thing would be our u. So we have to solve cosine of 6x minus pi, and that the u prime of that would be negative 6 sine 6x minus pi. And again, we add the negative because that's what the rule tells. Afterwards, we cancel, and the negative 12 and the negative 6 give us a 2. The next step would be to add 1 more to the exponent of u and divide by that number. After we do that, we just substitute for the u and add the two integrals to get the final answer.